Chemical reactions happen all around us every day. Substances change into other substances. But how do we represent these reactions? We notate them in chemical equations.
A chemical equation is the symbolic representation of a chemical reaction as an equation that identifies the reactants and products. The quantity of reactants or starting substances is on the left side, and the quantity of products, the final substances, is on the right side.
Chemical equations must be balanced in order to determine the starting and ending amount of the substance involved in reactions. A balanced chemical equation gives us more information about a reaction, such as the proportion of reactant to products, how many moles of each substance there is, and how many atoms of molecules are present.
A mole is a standard unit used to measure the amount of a pure substance equal to the quantity of 12 grams of carbon-12. This is about 6.02 times 10 to the 23rd atoms, also known as Avogadro's number.
Balancing equations is also an important part of stoichiometry. Stoichiometry is a part of chemistry that deals with the substances involved in chemical reactions.
In balanced chemical equations, you have coefficients or the number before a substance, and subscripts, the small number underneath substances. The coefficients represent the number of molecules of the particular substance that are present. They also represent the number of moles of that substance that are available.
For example, in this equation, 2H2O plus oxygen yields 2 water molecules. The coefficients indicate that 2 molecules of hydrogen interact with 1 molecule of oxygen to create 2 molecules of water. The subscripts indicate that there are 2 hydrogen atoms bonded together and 2 oxygen atoms bonded together in each of their respective molecules.
The most important thing to know about balancing a chemical equation is the law of conservation of mass. It states that in a chemical reaction, no mass is created nor destroyed. The amount of substance that you begin with in a reaction will equal the amount that you end with. In other words, the reactants must equal the products.
Before you balance a chemical equation, you start out with a skeleton equation. Skeleton equations are equations that use only the chemical formulas. They tell substance identities and how many atoms are bonded together, but do not show the proportionate quantities of the reactants and products in relation to one another.
For example, in Mg plus O2 yields MgO, it is shown that magnesium reacts with an oxygen molecule to form magnesium oxide. It shows that the formula for magnesium is Mg, oxygen is O2 because there are 2 oxygen atoms bonded together, and the product is magnesium oxide or MgO. However, skeleton equations are also called unbalanced equations. As you can see, there is 1 Mg on each side of the equation. However, there are 2 atoms of oxygen on the left, and in the end there's only 1. How is that possible? The answer is that it's not. You must balance the equation.
Balancing an equation is simple if you approach it the correct way, and if done correctly, you should end up with the same mass on either side of the equation due to the law of conservation of mass. For example, in the equation H2 plus O2 yields H2O, you would start by finding the number of atoms/molecules of an element on both sides of the equation.
In this equation, there are 2 atoms of hydrogen on the left and 2 on the right, so hydrogen is balanced. However, there are 2 oxygen atoms on the left and only 1 on the right, so those need to be balanced. The way to go about balancing the atoms is to use coefficients. All coefficients must be simple whole numbers, so to get the number of oxygen equal, a coefficient of 2 should be placed in front of H2O, meaning there are now 2 oxygen atoms on each side.
Now the hydrogen elements are off balance because there are 4 on the right and only 2 on the left. This is a simple fix, and all that is needed is a 2 coefficient in front of the H2. Now the equation is completely balanced with 4 hydrogen atoms on either side and 2 oxygen atoms.
Here is another example. You are given the skeleton equation C3H8 plus O2 yields H2O plus CO2. In this equation, you can see that there are 3 carbon atoms on the left and 1 on the right. 8 hydrogen atoms on the left and 2 on the right, and 2 oxygens on the left and 3 on the right.
An easy place to start on this equation is to put a 4 coefficient in front of H2O to balance out the hydrogens. Next, to balance the carbon atoms, put a 3 in front of the CO2. Finally, you can finish it off by placing a 5 in front of the O2, making it all even.
Thanks for watching. We hope this video was somewhat educational.